Welcome to Science to Sleep By. Tonight, as the world around you slowly grows quieter, and your breathing becomes softer, we're going to travel far beyond the noise of Earth, far beyond city lights, beyond the familiar stars, into a place where the universe itself seems confused. Somewhere in the deep cosmic dark, scientists have discovered a hole in space, a hole that doesn't behave like it should. It bends gravity in the wrong way. It treats light strangely, and it exists where nothing like it should exist at all. Tonight's story isn't meant to alarm you. It's meant to slow your thoughts, relax your mind, and gently remind you how vast, mysterious, and beautifully calm the universe truly is. So get comfortable, let your shoulders drop, and as we begin, allow yourself to drift into the strange calm of a cosmic whole that breaks every rule we know. Out in the vastness of the universe, there are places where silence feels heavier than darkness, regions where nothing dramatic seems to happen, yet something deeply unsettling quietly reshapes the motion of stars and the flow of time. Keyword 1 begins exactly there, with the cosmic hole that, according to everything we thought we understood, simply should not exist. For decades, astronomers believed black holes followed a clear set of rules. They were born from massive stars that ran out of fuel, collapsed under their own gravity, and left behind a dense core so powerful that not even light could escape. These objects had predictable masses, predictable signatures, and predictable effects on their surroundings. When scientists searched the sky, they expected to find black holes only where massive stars once lived. But this cosmic hole appeared in a place where no such star could have existed, like a footprint in the sand with no one around to make it. What first drew attention wasn't a dramatic explosion or a violent burst of radiation. It was subtle. Stars near a seemingly empty region of space were moving oddly, as if tugged by an invisible hand. Their orbits bent and stretched in ways that didn't match the gravity of visible matter. At first, astronomers assumed dark matter was responsible, but calculations didn't quite fit. Something else was there, something dense, something powerful, and yet, nothing could be seen. As telescopes grew more sensitive and observations more precise, the mystery deepened. This region lacked the bright accretion disk usually seen around black holes. There was no glowing ring of superheated gas screaming its presence across the cosmos. Instead, there was quiet, an absence so complete it felt intentional. The universe seemed to be hiding something in plain sight. What made this hole especially unsettling was its size. It was too massive to be a stellar black hole, yet too small to be a supermassive one. It sat awkwardly between known categories, like a sentence that doesn't belong in any paragraph. According to current models of cosmic evolution, there simply wasn't enough time or material in that region of space for such an object to form. And yet, there it was, unmoving, silent, and stubbornly real. Scientists began to revisit the earliest moments of the universe for answers. In the first fractions of a second after the Big Bang, space expanded violently. Density fluctuated wildly. Matter clumped in chaotic patterns before stars, galaxies, or even atoms existed. Some theorists suggest that under these extreme conditions, tiny regions could have collapsed directly into black holes, bypassing stars entirely. These are known as primordial black holes, and if this cosmic hole is one of them, it would be a relic from the birth of the universe itself, older than light, older than galaxies, older than time as we experience it. But even that explanation struggles to fit perfectly. The mass of this hole doesn't align neatly with predictions. Its gravitational influence behaves strangely, as though it's slightly out of sync with the fabric of space-time around it. Objects passing nearby don't always accelerate smoothly. Some seem to hesitate, drifting momentarily like leaves caught in slow-moving water. This behavior suggests that whatever this hole is, it may not be made of matter in the way we understand it. Another possibility is even more exotic. Some physicists propose that this object might not be a black hole at all, but something that only looks like one from afar. A gravistar, for example, is a theoretical object where collapsing matter never forms a singularity. Instead, it freezes in place, held up by quantum pressure. From the outside, it would appear almost identical to a black hole, but inside, the rules would be completely different. No infinite density, no point of no return. Just an impossibly dense shell wrapped around a strange, quiet core. The unsettling beauty of this idea is how gentle it is. There's no destruction, no tearing of reality, just a pause. Matter falling inward slows, then stops, suspended forever. If this cosmic hole is something like that, it challenges the very concept of collapse. It suggests the universe may have more ways of resolving extreme gravity than we ever imagined. What makes this discovery so powerful isn't fear, it's humility. For centuries, humans have tried to categorize the cosmos, to label everything neatly, to draw boxes around infinity. But this hole refuses to be boxed. It exists in defiance of our charts and equations, quietly reminding us that knowledge is always provisional. And yet, there is comfort in this defiance. The universe is not broken because something unexpected exists. It's alive with complexity. This hole does not threaten Earth. It does not move toward us. It does not consume recklessly. It simply exists, calmly bending space around it, like a deep breath held since the dawn of time. As you imagine this place, far beyond our galaxy, let its stillness sink in. No noise, no chaos. Just gravity doing something slightly different, slightly unfamiliar in the endless dark. This cosmic hole shouldn't exist according to old rules. But the universe has never promised to follow only the rules we know. And perhaps that's the most soothing thought of all. Even in the deepest unknowns, there is order of some kind. Even in cosmic mystery, there is patience. This hole waits, quietly, as scientists observe and wonder. It has waited for billions of years already. It can wait longer still. So as your thoughts begin to slow, let this impossible object drift gently through your mind. Not as a threat, but as a reminder. The universe is vast enough to hold contradictions, calm enough to keep secrets, and kind enough to let us rest beneath its unanswered questions. When scientists first began to suspect that this cosmic hole was real, they naturally turned to the most reliable guide they have ever had for understanding gravity, Einstein's general theory of relativity. For more than a century, this theory has described how massive objects curve space and time, how planets orbit stars, how galaxies hold together, and how black holes bend reality to their will. Time and again, Einstein's equations have survived every test. And yet, when applied to this strange object in the dark, something felt slightly off. In most regions of the universe, gravity behaves like a deep but predictable slope. The more massive an object, the steeper the curve it creates in space-time. Stars follow smooth orbits. Gas spirals inward in elegant arcs. Even near black holes, where gravity becomes extreme, the mathematics still works beautifully. Predictions match observations with astonishing precision. But around this cosmic hole, gravity seems to hesitate. It doesn't always pull with the steady certainty we expect. In some directions, its grip feels unusually strong. In others, oddly gentle. The curve of space appears warped in a way that doesn't fully agree with the equations on the page. Astronomers notice this first by watching stars nearby. Instead of tracing clean, repeating orbits, some stars drifted unpredictably as if they were navigating a landscape that subtly changed beneath them. Their paths showed tiny deviations, small enough to be missed at first, but persistent enough to raise quiet concern. Over years of observation, these deviations didn't average out. They remained stubborn and consistent, suggesting that gravity itself was behaving differently in that region of space. One possible explanation was that unseen matter was interfering. Clouds of dark matter clumped unevenly around the hole. But when researchers modeled these scenarios, the numbers refused to cooperate. The distribution required to explain the motion was too precise, too artificial. Nature rarely arranges itself so neatly. Something else had to be influencing the gravitational field, something more fundamental than invisible mass. Closer analysis revealed that space-time around the hole might not be smoothly curved at all. Instead, it appeared subtly distorted, almost rippled, like fabric, pulled tight in some places and loosened in others. These distortions could explain why gravity felt uneven, why objects didn't fall inward as cleanly as expected. But such ripples shouldn't exist on this scale unless something extraordinary had happened in the object's past, or unless gravity itself behaves differently under certain conditions we have yet to understand. This possibility unsettles physicists in the gentlest way. It doesn't suggest chaos or collapse, but incompleteness. General relativity, for all its success, does not include quantum mechanics. It describes gravity beautifully on large scales, but it cannot explain what happens at the smallest, deepest levels of reality. Near this cosmic hole, those two realms may be overlapping. Gravity might be brushing against quantum effects, softening or reshaping its influence in subtle ways. Some researchers suggest that what we are seeing is not gravity breaking, but gravity revealing a second layer, one that only appears in extreme environments. In this view, Einstein's equations are still correct, but incomplete, like a map that shows continents but not ocean currents. Around this hole, those hidden currents become visible, gently steering matter in ways our current models can't fully predict. The idea becomes even more intriguing when time is added to the picture. Near most massive objects, time slows predictably. Clocks run slower closer to strong gravity, a fact proven by satellites orbiting Earth. Around this cosmic hole, however, calculations suggest time dilation that varies unevenly with direction. Time seems to stretch more in some regions than others, as if the flow of seconds itself is being gently twisted. This uneven slowing of time could explain why gravity appears inconsistent. If time doesn't flow uniformly, then motion, acceleration, and force would naturally feel distorted. Objects wouldn't simply fall, they would drift, pause, or curve unexpectedly. From a distance, it might look like gravity is misbehaving, when in reality, time itself is being reshaped. What's remarkable is how calm this process appears to be. There are no violent bursts of energy, no tearing of space, no dramatic signals screaming danger. The universe isn't panicking, it's quietly experimenting, revealing a version of gravity that is softer, more complex, and more nuanced than we ever imagined. This challenges one of our deepest assumptions, that gravity is the most straightforward of the fundamental forces. We often think of it as simple and universal, always attractive, always predictable. But this cosmic hole suggests that gravity may have mood states that depend on environment, scale, and history. Under normal conditions, it behaves exactly as Einstein described. Under extreme ones, it may whisper a different story. For scientists, this is not a failure of understanding, but an invitation. Every deviation is a clue. Every anomaly is a doorway. The universe is not mocking our theories. It's guiding us toward deeper ones. This hole doesn't overthrow relativity, it extends the conversation. And for you resting here and listening, there is something profoundly soothing about this idea. Even the force that binds galaxies and shapes the cosmos is not rigid or harsh. It can bend gently. It can adapt. It can surprise without threatening. As you imagine this strange gravity, picture it not as a crushing pull, but as a slow, uneven tide in a cosmic ocean. A tide that ebbs and flows, guided by rules we are only beginning to sense. Nothing snaps. Nothing breaks. Everything moves at its own patient pace. This cosmic hole doesn't rage against the laws of gravity. It simply leans against them softly, revealing where they flex. And in that quiet flexing, that gentle disobedience, the universe reminds us of something comforting. In its deepest mysteries unfold slowly, calmly, and without urgency, just like sleep itself. Light is usually the most honest storyteller in the universe. It moves at a constant speed, follows predictable paths, and carries with it clear information about where it has been and what it has encountered. Astronomers trust light more than anything else, because even across billions of years, it rarely lies. Yet around this cosmic hole, light begins to behave in ways that feel hesitant, distorted, and strangely uncertain, as though the universe itself is pausing before revealing the truth. Under normal circumstances, when light passes near a massive object, it bends smoothly. This effect, known as gravitational lensing, has been observed countless times. Galaxies stretch into graceful arcs, distant stars appear duplicated, and space acts like a giant, gentle magnifying glass. Around black holes, this bending becomes extreme, creating a bright ring of light surrounding a deep shadow. The geometry is precise, almost elegant. But near this cosmic hole, that elegance dissolves into something softer and harder to define. Instead of a clean, symmetrical lens, astronomers observe light that appears smeared, uneven, and slightly blurred. The expected ring does not fully form. Some photons vanish more quickly than models predict, while others linger, taking longer paths than expected. It's as if light can't decide which route to follow, wandering through a region where space itself seems unsure of its shape. This strange behavior suggests that the fabric of space around the hole is not smoothly curved, but subtly uneven. Imagine walking across ground that looks flat but gently shifts beneath each step. You wouldn't stumble, but you wouldn't walk in a straight line either. Light experiences something similar here. It isn't violently scattered or torn apart. It simply drifts, guided by a geometry that feels incomplete. One of the most puzzling observations is how dim the region appears compared to expectations. Black holes are often surrounded by glowing disks of hot gas, shining brightly in X-rays and radio waves. Even when a black hole is quiet, the bending of background light usually reveals its presence. This cosmic hole, however, seems to absorb light without announcing itself. Background stars fade slightly as their light passes near it, but without producing the dramatic distortions astronomers are used to seeing. This has led scientists to consider whether the hole's boundary, the region where gravity becomes overwhelming, might not be as sharply defined as an event horizon. If that boundary is fuzzy or layered, light approaching it could scatter internally, losing energy in tiny, gradual steps rather than vanishing all at once. From far away, this would look like light being gently erased rather than abruptly swallowed. Another intriguing possibility is that light itself is interacting with something exotic. In extreme environments, quantum effects can subtly influence photons. Space may not be perfectly empty near this hole. It might be filled with fluctuating energy fields that tug on light in unpredictable ways. Each photon passing through could experience a slightly different path, leading to the soft blurring observed from Earth. Time also plays a role in the strangeness. As light moves through regions of strong gravity, time slows. But if time dilation varies unevenly around the hole, then photons traveling along different routes would experience different speeds of time. Some would arrive earlier than expected, others would be delayed. To our instruments, this would appear as light stretching and fading, not because it's weaker, but because its journey has been quietly reshaped. What makes this phenomenon so mesmerizing is its gentleness. There are no violent flares, no sudden flashes, no warning signs of danger. Light doesn't scream as it disappears. It whispers, slowly losing definition, like sound fading into thick fog. The universe is not tearing light apart, it's cradling it, guiding it into a place where clarity dissolves. This challenges our intuition about darkness. We often imagine cosmic darkness as empty or hostile, but here, darkness is active. It's doing something. It's shaping the way light behaves, influencing what we can see and what remains hidden. This hole doesn't just block light. It transforms the journey of seeing itself. For astronomers, this creates a quiet frustration and a deep fascination. Light is their primary tool, and when it behaves strangely, it forces them to rethink their assumptions. If light cannot be trusted to move cleanly through this region, then perhaps space-time itself is layered, textured in ways we haven't yet mapped. For you listening and resting, there is something calming in this uncertainty. Light, the fastest and most restless traveler in the universe, slows down here. It hesitates. It drifts. It loses urgency. In a way, this cosmic hole teaches light how to rest. Imagine a beam of starlight leaving its home millions of years ago, traveling tirelessly through the void, until it reaches the strange region. There, it softens. Its path curves gently. Its brightness dims, not from exhaustion, but from surrender. It doesn't vanish in fear, it fades in acceptance. This is not the darkness of destruction. It is the darkness of quiet transformation, the kind that doesn't demand attention, but rewards patience. The kind that reminds us that not everything needs to be sharp or defined to be meaningful. As your thoughts slow and your mind begins to drift, let this image settle gently. Light moving calmly into uncertainty, space bending softly around it. No rush, no struggle, just a slow, peaceful loss of edges. In this cosmic whole, even light learns to let go. And in that letting go, the universe offers a lesson both scientific and soothing. Sometimes, the most profound mysteries are not loud or dramatic. They are subtle, dim, and patient, waiting quietly, just beyond the reach of clarity, inviting us not to fear the dark, but to rest within it. In the universe, silence is rarely empty. Even the darkest, loneliest regions of space are usually filled with whispers, radio waves from distant stars, X-rays from hot gas, faint hums of energy drifting across the cosmos. Astronomers have learned to listen carefully to these signals, because every cosmic object has a voice. Black holes, despite their name, are rarely quiet. They crackle with radiation, flare as they feed, and announce their presence through subtle but unmistakable noise. That is why this cosmic hole feels so unsettling. It is either far too quiet, or, a strangely different way, far too loud. At first, scientists noticed the silence. Instruments pointed toward the region, expecting at least a faint signature, some radio emission, some X-ray glow, some evidence of matter falling inward. Instead, they found almost nothing. The area appeared unusually calm, like a deep space void where activity should be minimal. But this calm did not match the gravitational influence being observed. Something massive was there, something powerful enough to tug on stars, yet it refused to speak in the familiar language of radiation. Normally, as matter spirals toward a black hole, it heats up dramatically. Gas collides, accelerates, and glows brilliantly, producing intense radiation long before it ever crosses the event horizon. This process turns black holes into some of the brightest objects in the universe. But around this cosmic hole, that process seems muted. Matter approaches, slows, and then goes quiet. There is no brilliant farewell, no energetic scream, just a gradual fading, as if the universe itself is lowering the volume. One explanation is that matter is not falling in violently at all. Instead of spiraling inward at high speeds, gas may be drifting gently, cooling as it goes. If the gravitational field around the hole is uneven or layered, matter could be losing energy gradually, radiating very little. This would create an object that is massive but dim, gravitational presence wrapped in near silence. But then there is the other side of the puzzle. When scientists look beyond traditional wavelengths, listening, not just with radio and X-ray telescopes, but with instruments sensitive to subtle background noise, they find something unexpected. A faint excess of low-level signals. Not sharp bursts, not flares, but a persistent, almost constant murmur. It's not loud in the conventional sense, but it's there, steady and strange, like static beneath a calm melody. This raises a fascinating possibility. The whole may not be silent at all. It may be speaking in a voice we rarely hear. Instead of dramatic emissions, it could be releasing energy slowly, evenly, across vast stretches of time. A cosmic whisper rather than a shout. If true, this would explain why it appears quiet to most instruments, yet subtly influences its surroundings in ways that feel noisy, in a deeply indirect sense. Some physicists suggest that this murmur could be linked to quantum processes near the hole's boundary. Tiny fluctuations in energy, happening constantly, could create a background hum too soft to stand out individually, but powerful in aggregate. Over millions of years, this gentle noise could shape nearby space, warming it just enough to affect matter and light without producing obvious radiation. Another intriguing idea is that the hole's environment acts like a soundproof room. Energy that would normally escape as radiation may be trapped, reflected inward, or converted into forms we can't yet measure easily. Instead of flaring outward, the energy circulates quietly like air moving through hidden vents. From far away, this looks like silence. Up close, it may be full of motion. This dual nature to quiet in some ways, too persistent in others, makes the whole feel almost alive. Not alive in the biological sense, but dynamic, balanced, self-contained. It doesn't erupt or collapse. It maintains a steady state, neither screaming nor sleeping fully, just existing calmly on its own terms. For astronomers, this is deeply unsettling and deeply beautiful. The universe has trained them to expect extremes. Bright or dark, loud or silent, active or dormant. This whole refuses to choose. It sits in between, challenging the idea that cosmic objects must announce themselves clearly to be understood. For you, listening now, this strange quiet holds a different meaning. Imagine a place so stable, so balanced, that it doesn't need to raise its voice. A place where energy flows without drama, where motion exists without noise. In a world that often feels loud and demanding, this cosmic whole offers a different model of power, one rooted in stillness. Think of the soft hum of a distant engine, barely audible, steady and reassuring, or the sound of wind far away, not howling, just breathing. This whole's voice is like that. Not empty, not chaotic, just present. As you settle deeper into rest, let this idea soothe you. Even the universe knows how to be quiet without being empty. Even immense forces can operate gently, without urgency or violence. This cosmic whole does not roar its existence into space. It doesn't compete for attention. It simply continues, influencing stars, bending space, and whispering its presence through subtle signals that take patience to hear. And perhaps that is its greatest lesson. Silence does not mean absence. Quiet does not mean weakness. Sometimes, the most powerful things in the universe speak so softly that you have to slow down, relax, and listen carefully to notice they are there at all. Time is usually one of the most dependable features of the universe. It flows forward, second by second, steady and predictable. Even when Einstein revealed that time can stretch and slow near massive objects, it still followed clear rules. The stronger the gravity, the slower the clock. Near planets, the effect is tiny. Near stars, it grows. Near black holes, time nearly comes to a stop. This cosmic whole, however, seems to treat time differently, almost unnaturally, stretching it in ways that feel deeper, quieter, and far less uniform than anything we have seen before. In familiar black holes, time slows smoothly as you approach the event horizon. Every clock closer to the hole ticks more slowly than one farther away, and the transition is gradual and mathematically precise. Astronomers can calculate exactly how much time should slow at any distance. But observations around the strange object suggest something more complex. Time does not simply slow more and more, it slows unevenly. In some regions, time appears to stretch far beyond predictions. In others, it behaves almost normally, even though gravity should be overwhelming. This uneven slowing reveals itself indirectly, through motion. Objects orbiting the hole don't just move more slowly, they hesitate. Their paths seem to linger in certain regions of space, as if caught in invisible pockets where time is thicker. It's not that they stop, it's that moments themselves feel longer there. From a distance, it looks as though reality is taking a breath and holding it. Light, too, carries evidence of this distortion. Photons traveling near the hole arrive slightly later than expected, even after accounting for known gravitational effects. Some signals stretch out, their wavelengths lengthen more than models predict. This suggests that time itself is being pulled and folded, not smoothly, but in gentle layers. One possibility is that the hole's interior structure is not simple. If the object does not collapse into a single, infinitely dense point, then the way it influences time may be more distributed. Instead of one dominant source of time dilation, there could be multiple regions contributing, each stretching time by a different amount. The result would be a landscape of time rather than a single slope, a place where seconds do not all weigh the same. This idea aligns with theories that involve quantum effects. At extremely small scales, time may not be continuous. It may come in tiny steps, flickering and fluctuating. Near this cosmic hole, those fluctuations could become large enough to influence macroscopic reality. Time would still move forward, but not evenly, creating zones where it flows more slowly, almost syrupy, compared to the surrounding space. What makes this especially fascinating is how calm it appears. There is no violent tearing of time, no catastrophic paradoxes. The universe is not breaking its own clock. It's simply allowing it to stretch more than usual, like elastic pulled gently but persistently. This slow stretching creates an environment where change happens, but without urgency. If you were somehow able to observe this region from nearby, you wouldn't see chaos. You would see patience, matter drifting, light lingering, motion soften. The universe, in that place, seems in no hurry at all. This extreme time dilation has profound implications. It means that events near the whole unfold at a different rhythm than the rest of the cosmos. A process that takes minutes elsewhere could take hours there. A collapse that seems instant from afar might feel endlessly slow up close. In a sense, this hole creates a sanctuary of slowness, a pocket of deep cosmic stillness. For scientists, this challenges the idea that time dilation is always smooth and predictable. It suggests that under certain conditions, time can develop texture. It can fold, pool, and stretch in ways that feel almost organic. This doesn't contradict relativity, it hints at layers beneath it, waiting to be understood. For you, listening and resting, there is something profoundly comforting in this image. A place where time itself slows more than expected, where moments stretch gently, giving everything space to exist without pressure. In our everyday lives, time often feels rushed, demanding, relentless. But the universe contains places where time softens, where urgency dissolves. Imagine drifting near this cosmic lot, falling, accelerating, just floating. Each second feels longer than the last. Thoughts slow, sensations soften. There is no deadline, no countdown, no rush toward anything. Just an endless present, expanding quietly. This unnatural slowing of time does not threaten the universe. It does not trap it. It simply reminds us that time is more flexible than we usually believe. It can bend not only under force, but under complexity. It can adapt. As you let your own breathing slow, allow this idea to settle in. Somewhere in the universe, time is stretching far beyond what we expected. Not violently, not dramatically, just gently, patiently, like a long, deep exhale that never quite ends. And in that cosmic pause, in that extended moment, the universe offers something rare and soothing, proof that even time itself knows how to slow down and rest. As scientists continued to observe this strange cosmic hole, a quiet realization began to settle in. The data did not simply suggest an unusual black hole. It suggested something more unsettling and more fascinating at the same time. What if this object was never a traditional black hole at all? What if it belonged to a category of cosmic structures that exist mostly in equations, hypotheses, and whispered conversations between physicists late at night? A traditional black hole follows a familiar story. A massive star exhausts its fuel, collapses under its own gravity, and forms a singularity wrapped in an event horizon. That horizon marks a clear boundary, cross it, and nothing returns. But the object being studied did not display the clean signatures of this process. There was no clear evidence of a collapsed star, no violent birth, no definitive edge where reality abruptly ends. Instead, there was ambiguity, softness, and patience. One of the most compelling alternatives is the idea of a primordial black hole. These hypothetical objects would have formed not from dying stars, but from density fluctuations in the earliest moments of the universe. In the chaotic aftermath of the Big Bang, tiny regions of space could have become so dense that they collapsed directly into black holes. If this cosmic hole is primordial, it would be unimaginably old, older than galaxies, older than stars, older than light itself as we usually think of it. Its behavior would reflect conditions from a universe still learning how to exist. Yet even primordial black holes are expected to obey many of the same gravitational rules as stellar ones. And this object still seems to resist full explanation. That leads to even more exotic possibilities, ones that gently blur the line between black holes and something else entirely. Consider the concept of a gravistar, short for gravitational vacuum star. In this theory, collapsing matter never reaches infinite density. Instead, as gravity intensifies, quantum effects intervene. The collapse slows, freezes, and stabilizes. What forms is a shell of ultra-dense matter surrounding a core of strange vacuum energy. From the outside, it looks almost exactly like a black hole, but inside, there is no singularity, no infinite point, and possibly no event horizon in the traditional sense. If this cosmic hole is a gravistar, it would explain many of its odd behaviors. The lack of intense radiation, the softened boundary, the strange way gravity and time seem layered rather than absolute. Matter approaching such an object wouldn't crash violently inward. It would slow, linger, and perhaps never truly cross into a point of no return. This would make the object feel calm, almost suspended in a permanent state of near collapse. Another possibility is even more provocative: a naked singularity. In this scenario, a singularity exists without an event horizon to hide it. According to classical physics, such objects should not exist. The universe, it seems, prefers to keep its infinities concealed. But if extreme conditions allow a singularity to remain exposed, it could produce exactly the kind of unpredictable gravitational and temporal effects being observed. Light, time, and matter would behave strangely near such an object, not because the laws of physics are broken, but because they are being pushed to their absolute limits. There are also ideas that blend these concepts together. Hybrid objects that begin collapsing like black holes, but are stabilized by unknown forces. Structures that look like holes from afar, but are something else up close. Cosmic imposters that wear the mask of a black hole while following a different internal logic. What makes all of this so compelling is how gentle the mystery remains. This object is not tearing the universe apart. It is not threatening galaxies or consuming stars indiscriminately. It simply exists, quietly challenging definitions. It forces scientists to ask not what is wrong, but what else is possible. For physics, this is a profound moment. Black holes have long been treated as endpoints, the final chapter in the story of massive matter. But this cosmic hole suggests there may be alternative endings, different resolutions, softer conclusions that avoid infinities and singularities altogether. For you, resting and listening, this idea carries a subtle comfort. Even in the most extreme conditions, the universe may choose balance over destruction. It may pause instead of collapse. It may hold itself together in ways that are calm, quiet, and deeply patient. Imagine an object so massive, so intense, yet so restrained. Instead of screaming into existence, it whispers. Instead of tearing reality apart, it bends it gently. It does not demand to be understood immediately. It waits. This cosmic hole may not be a black hole as we know it. It may be a reminder that our categories are provisional, definitions temporary. The universe is not obligated to fit neatly into our boxes. It is free to surprise us softly. As your thoughts begin to drift, let this possibility settle in your mind. Somewhere in the universe, there may be objects that sit between states, neither star nor hole, neither collapse nor stability. Objects that exist in the quiet space between certainty and mystery. And in that in-between space, the universe reveals something deeply soothing. Even the unknown does not have to be violent. Even the most extreme cosmic mysteries can unfold gently, inviting us not to fear what we don't yet understand, but to rest within the wonder of it. As all these strange observations come together: the uneven gravity, the softened light, the quiet radiation, the stretched and patient flow of time, it's natural for the human mind to drift toward unease. A cosmic hole that behaves differently can sound unsettling at first, but when scientists step back and look at the full picture, a calmer truth emerges. This object, for all its mystery, is not a threat. It is not a warning. It is a gentle reminder that the universe is far more stable, patient, and forgiving than our fears often suggest. Despite its unusual nature, this cosmic whole is incredibly distant. It exists far beyond our galaxy, separated from Earth by expanses of space so vast that even light takes immense time to cross them. Its gravitational influence, while strong locally, fades quickly with distance. By the time its presence reaches our corner of the cosmos, it has softened into nothing more than a subtle whisper among countless other gravitational effects. Our planet continues its quiet orbit, our sun burns steadily, and the Milky Way drifts peacefully through space, entirely unaffected. What's important to understand is that anomalies like this do not signal instability in the universe. Quite the opposite. They reveal how resilient cosmic systems truly are. The universe has existed for billions of years, surviving far more violent events than this: colliding galaxies, exploding stars, massive black holes tearing through matter. And yet, here we are, in a calm era of cosmic history, watching from a safe distance as the universe gently reveals its deeper layers. This cosmic whole is not expanding uncontrollably. It is not consuming everything around it. It is not moving toward us. It is simply there, quietly shaping its immediate surroundings in ways that invite curiosity rather than fear. Its behavior suggests balance, not danger; stability, not collapse. In fact, the very strangeness of this object may point toward a universe that avoids extremes. Instead of allowing matter and energy to reach infinite, destructive states, the cosmos may have built-in mechanisms that soften those outcomes. Time stretches instead of breaking. Gravity layers instead of snapping. Light fades instead of screaming. These are not signs of chaos. They are signs of regulation. For scientists, this realization is deeply reassuring. It suggests that the universe is not fragile. Its laws are not brittle rules waiting to shatter. They are flexible principles that adapt under extreme conditions. When pushed, reality does not tear, it bends, gently and intelligently. For you, listening now, this perspective offers something even more comforting. In a world that often feels unpredictable and intense, the universe itself models patience. Even its greatest mysteries unfold slowly. Even its most extreme objects behave calmly. There is no urgency written into the fabric of space-time, no countdown toward disaster. There is only motion, balance, and time, vast amounts of time. Imagine this cosmic whole not as a void of danger, but as a quiet anchor in space. It holds its place. It influences without overwhelming. It exists without demanding attention. In its stillness, it mirrors something deeply human: the idea that strength does not require noise, and mystery does not require fear. This is why astronomers can study such objects without anxiety. Discovery does not mean doom. Knowledge does not bring catastrophe. Instead, each new understanding brings perspective. The more we learn about the universe, the more we realize how rare and protected our everyday experience truly is. Earth is not perched on the edge of cosmic chaos. It is nestled within a vast, stable structure that has room for anomalies without being threatened by them. As the night deepens and your thoughts begin to soften, let this realization settle in. Somewhere far away, a strange cosmic whole quietly exists, following rules we are still learning to describe. It does not rush. It does not threaten. It simply reminds us that the universe is bigger than fear and slower than worry. The stars above you are steady. The galaxy continues its graceful rotation. Time on Earth flows gently forward. Nothing about this mystery changes that. Nothing about this whole reaches into your world. And perhaps that is the most soothing truth of all. The universe is full of wonders that challenge our understanding, but very few that endanger our peace. Most mysteries are invitations to observe, to learn, to marvel rather than reasons to be afraid. As we gently arrive at the end of this journey, it's worth pausing for a moment, not to solve the mystery, but to sit quietly beside it. This cosmic whole, so strange and so unlike anything we expected, does not ask for fear or urgency. It asks for patience. It asks for wonder. And most of all, it invites us to slow down and listen to the universe in a deeper way. Throughout this story, we've seen how nothing about this object behaves normally. Gravity bends unevenly. Light loses its certainty. Time stretches in unfamiliar ways. Signals whisper when they should shout, and silence appears where noise is expected. And yet, in all of this strangeness, there is no violence, no chaos, no threat. Just a quiet reminder that the universe is far more subtle than our first impressions often allow. We often imagine cosmic mysteries as dramatic explosions, collisions, endings. But this mystery unfolds differently. It is calm. It is restrained. It exists without urgency, as though the universe itself is comfortable not having all the answers immediately revealed. In a way, this cosmic whole feels less like a rupture in reality, and more like a pause. A long, patient breath, held across billions of years. For scientists, this object expands the boundaries of understanding. It doesn't erase what we know, it builds gently upon it. It suggests that the laws of nature are not brittle rules, but flexible principles, capable of adapting to extremes without breaking. Gravity doesn't fail here. It deepens. Time doesn't stop. It softens. Light doesn't disappear in panic. It fades with grace. And for you, here at the end of the day, this story carries a quieter meaning. In a world that often feels rushed, loud, and demanding, the universe offers a different rhythm. It shows us that even immense power can be gentle, that even deep mystery can be calm, that not knowing everything right away is not a flaw, but a feature of existence itself. Somewhere far beyond the Milky Way, this cosmic whole continues to exist exactly as it has for ages, unchanging, unbothered, unhurried. It does not move toward us. It does not disturb our sky. It simply holds its place in the vastness, a silent reminder that the universe is large enough to contain both order and mystery in perfect balance. As you let your thoughts slow, remember this: the same universe that contains strange gravity and unfamiliar time also contains quiet nights, steady stars, and a planet where you can safely rest. Nothing about this cosmic whole reaches into your world. Nothing about it disrupts your sleep. It exists far away, doing what the universe has always done, exploring itself through endless variation. So there is no need to stay alert. No need to hold on to questions. Curiosity can rest now. Wonder can soften. The mystery will still be there tomorrow, and the universe is in no rush to resolve it. Let the idea of this calm, impossible object drift gently into the background, like distant starlight fading at the edge of vision. Let the vastness feel reassuring instead of overwhelming. You are not small in the universe, you are sheltered within it. And as the final thought settles, take comfort in this quiet truth. The cosmos is full of things that are not normal, yet almost everything about it is peaceful. The universe continues its slow, steady motion. The stars remain in place. Time flows gently forward, and you are free to let go, to relax, and to sleep.